In a disease process where your body's breaking down, it's subject to stress, it starts to get unbalanced, and symptoms occur. They're the last thing to occur in a disease process. It doesn't matter if you're tired, fatigued, sinuses, allergies, moodiness, irritability, whatever it might be. Those are just the symptoms. They're signals something's wrong, and sometimes it's easy to get rid of them. You can take something for just about everything these days. But that doesn't fix you, that doesn't make you better.
The cause of dying of neurological disease, especially 80% of that being Alzheimer's disease, in women in the last 20 years has increased 663% in 20 years, which is an unbelievable, unconceivable number. And there is suggestions from the epidemiological community that half of the population alive right now in the West will die either with or of Alzheimer's disease. There's virtually no effort on government side, on policymakers to change that. There is an effort to fund ridiculous research and trying to create a drug to stop it, rather than looking at the causes and stopping those which are well known.
Alzheimer's is going out of sight, just like autism. It's terrifying. I think it was something like 15% of people alive today can be expected to be diagnosed with Alzheimer's in their lifetime. That is terrifying.
When patients come to my office, one of the biggest things I assess for is how healthy is your mitochondria. And one clue to that is their premature aging. Things like wrinkling of the skin at an earlier age or graying of the hair, fatigue.
When we look at the mitochondria, I mean, they're the powerhouse. They're basically the battery of the cell. So how well is your car going to run if you don't have a battery? Really, nothing's going to happen. That's what you need, that spark to generate everything to get your car to move. Or you need that battery charge to get your phone to work. And if that battery's not producing energy, nothing's going to happen. And that's the same thing in the brain. When the mitochondria are not functioning optimally, everything just goes down. You can't get a neuron to fire properly.
Mitochondria basically behave like bacteria. So if we have 100 quadrillion of them, we have 100 quadrillion bacteria that are actually moving around our body. Now, the way they reproduce is by fission. They divide, right? Just like any bacteria do. And then the way they move about is they either fuse with other mitochondria, forming long strands for when you need lots of energy. And in your neurons, where there are long axonal strands, for example, for the delivery of signals in the nerve cell, then the mitochondria actually move up and down. So there's fusion, there's fission, there's movement, and then there's this phenomenon called mitophagy. So what happens when a mitochondrion actually divides is that the division is very uneven for the number of mitochondria that would go from one cell that's dividing to the other. Now, if there's a lot of damaged mitochondria that goes to one cell, then the mitochondria detect that or sense that, and it will send out signals such that the cell would commit suicide.
Mitophagy is an excellent process because it recognizes damaged mitochondria, and if mitochondria are damaged, they produce less ATP, and besides, they stimulate production of reactive oxygen species. If these mitochondria are eliminated, it will be really beneficial for cells and for organisms in general. Some cells can become dangerous for us. And if cell doesn't fulfill its function, it's better to kill it. In cancer, for example, apoptotic program is suppressed. That leads for uncontrolled growth of tissue. That's why if you stimulate cell death, apoptotic cell death, you might cure cancer. Apoptotic cell death is painless. I read that every day in our body, about 1.2 kilograms of cells die by apoptosis, but we don't feel it. But it's necessary form of cell death because cell divide, proliferate, and to keep shape and form of our organs, some cells should die. In cancer, as I mentioned, apoptosis is suppressed. But if we have too much apoptosis, this might lead to different neurodegenerative diseases like Alzheimer's disease, Parkinson's disease. So it must be really balanced.
The mitochondria in your cells decide whether or not you're going to get most kinds of cancer. And if they are poisoned by the environment, they're poisoned by your food, there are other things going on, when they realize they can no longer effectively take air and food to make energy, say, well, I'm going to make energy some other way. And they start making energy through a process that's more like fermentation that requires a lot less air. They become something called pseudo-hypoxic. And when this happens, you get cancer. And you can turn this around. And just by taking care of your mitochondria, you reduce your incidence of every kind of disease, including cancer and heart disease and diabetes, all the big killers, Alzheimer's, all of them improve when your mitochondria improve.